Hello everyone. This is the lecture series of operation research subject. This is lecture number 3 and code of this subject is 405. This is unit number 1 and lecture number 3. Myself Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan, Vihar University, Jaipur. And today I will discuss about the linear programming simplex method. It is already stated in the previous lecture that the most powerful method used for the solution of linear programming problems, used for the solution for linear programming problem is the simplex method. But in the last class, I was discuss about the graphical method, means how to solve the linear programming problem with the help of graphical method, because linear programming problems can be solved by the different method. So first method is graphical method and second is simplex method, right? But in this lecture, motivation for simplex method will be discussed first, right? And then simplex algorithm and construction of simplex table will be discussed later with an numerical example problem, right? With a numerical example problem. So, what is the objective of simplex method? The simplex method is used to eradicate the issues in linear programming. It examines the feasible sets adjacent vertices in sequence to ensure that at every new vertex, right? With the help of simplex method, uses a system symmetric strategy. Uses a system symmetric strategy to generate and test candidate vertex solution to a linear program. For this method, a student able to understand the simplex method is able to evaluate whether no solution actually exists. So these are the some objectives of this class for solving the problem related to the simplex method, and these problems related to the linear programming problem applications, right? And simplex method. Simplex method gives the concept solving profit maximization and cost minimization problem, and the cost minimization problem. Similar to the graphical method, it can also solve the maximization and minimization problem. But in this case, the problems are very typical, right? Typical, and the formulation of form and non-form linear programming model. This is the definition of simplex method. One question arises here: where is simplex method is used? If already I have a graphical method, so what is the use of simplex method? What is the use of simplex method? Simplex method, where is it used? Where the decision variables are more than 2. In the graphical method, or we can say that graphical method only solves 2 variables problem. But in this case, where the decision variable more than 2, it is always advisable to use simplex method to avoid lengthy graphical procedure, right? Simplex method is also avoid the lengthy graphical situation. Lengthy graphical situation, right? The simplex method is not used to examine all feasible solution. Means in this approach, you cannot solve all feasible solutions, right? It gives a one particular value for a fixed function, right? It deals only with a small and unique set of feasible solutions. It deals only with a small and unique set of feasible solutions. The set of vertex points, that is extreme points of the vertex feasible space that contains the optimal solution, that contains the optimal solutions, and these solutions related to the linear programming problem, right? For the motivation of this method, for the motivation of the simplex method, thus one way to find the optimal solution is to find all the basic feasible solution of a canonical form and investigate them one by one to get at the optimal. However, however, we again take one example. This is a for 10 questions with 15 variables. There exists a huge number. Then 15C 10 equal to the value of 3003 of the basic feasible solution. In such cases, inspection of all solution one by one is not practically feasible. However, this can be overcome by simplex method. This can be overcome by the simplex method. The simplex method gives a very good approach for following the feasible solution. The concept related to the simplex method. It is an algorithm adapted to solve logarithmic problem, which allows us to choose an initial basic feasible solution with all the real activities at zero level and disposal activities at the largest positive level to arrive at the optimal solution through iteration. Here, with the help of iteration, I can solve the different types of feasible solution, and it follows means this solution, this simplex method follows the shortest route to reach the optimal solution, to reach the optimal solution from the starting point, from the starting point, or we can say that it is the shortest route consists of a sequence of basic feasible solution, consists of a basic feasible solutions. That's why it generates a one simple algorithm. That's why it generates a one simple algorithm for the question, right? And this algorithm, how to solve how to solve this algorithm with the help of a optimal solution and iteration method. And what is the iteration method? This iteration method problem I will discuss in the next slides or coming slides also. And then the most popular method used to solution of linear programming problem is a simplex method. So simplex method is a very good solution to solve the problem by the LPP method if decision variable more than 2, right? And this solution is developed by George Dan Jig in 1946. This solution is developed by the George Dan Jig in 1946, right? So different steps involved for this process. So what the steps for this? Before starting these steps, I will give some general procedure of the simplex method. The general form of the given linear programming problem is transferred to its canonical form. First, you obtain this. Suppose this is a one question. This is the maximized problem. Just we convert this into the canonical form, and then the basic feasible solution of the LPP is found from the canonical form. There should be at least exist at least one here. Then move to the next next step. This initial solution is moved to an adjacent basic feasible solution, which is closed set to the optimal solution among all other adjacent basic feasible solutions. And this procedure is repeated until the optimal solution is not achieved, and this is done by the with the help of iteration process. And in the case of these steps involved to solve the problem, this is called the simplest algorithm. This is called the simplest algorithm, right? So just you see here for the simplex method problem. These are four steps involved for this problem is here. First is locate an extreme point of the feasible region. Locate an extreme point of the feasible region and examine each boundary edge. Examine each boundary edge intersecting at this point to see whether whether movement along any edge increases the value of the objective function, right? If the value of the objective function increases, if the value of the objective function increases along any edge, move along this edge to the adjacent extreme point. If several edge indicated improvement, the edge providing the greatest rate of increase is selected. Then they repeat the step 2 and 3. Repeat the step 2 and 3 till you cannot get a equal solution. So repeat the iteration. Repeat the iteration one by one, right? And these steps 2 and 3 until movement along any edge no longer increase the value of the objective function. Means objective function is value is fixed by the several iterations. So this is the solution. This is the solution of this problem, right? So this is one example for the simplex method profit maximization problem. This is the simplex method profit maximization problem, right? For the profit maximization problem, just to see this problem here, the industrious company produces two products. first and second, produces two products, first and second. The raw material requirements, first is space needed, first is space needed for storage. What the space needed for first case 4 and for the second case is 5, right? And for the production rate, what the production rate units per hour 60 for the first unit and 30 for the third third unit product, right? For the second unit product, right? And the selling prices is 13 and 11, and the raw material also 5 and 3. This is the one problem for the simplex method. If I will solve this problem with the help of simplex method, right? So the total amount of raw material available per day for both products is 1575 LB, and the total storage space for all products is 1500 square feet, and the maximum of 7 hours per day can be used for production. This is the constraints of the question. This is the constraint of the question, and the company want to determine how many units of each product, how many units of each product to produce per day, to maximize its total, income. Okay, to maximize its total income. For this case, these are the constraints given by the question, and just you follow the step number 1. Just you follow the step number 1. Convert all inequality constraints. Convert all the inequality constraints into equalities. Into the equalities by the use of slack variable. By the use of the slack variable. Let S1 an unused storage space. S1 is the unused storage space. S2 is the unused raw material, and S3 is the unused production time. So these are the S1, S2, S3 are the different type of constraint. Notation are here, right? As already developed, the linear programming model is maximized for this case z equal to 13x1 plus 11x1. Selling price. This is the maximum from 13x1 plus 11x2. These are subject to These are subject to 4x1 plus 5x2. This is a less than and equal to 1500, and 5x1 plus 3x2 less than and equal to 1575, and the x1 plus 2x2 equal less than equal to 420. Right? These are the constraints. For introducing this question, just convert this equation into the generalized form and introducing these slack variables. Slack variables are These are the slack variables S1, S2, and S3. These are the slack variables into the inequality constraints and rewriting the objective function such that the all variables are on the left hand side of the equation. Means all variables, these variables are left hand side of the equation, and equation 4 can be expressed as equation number 4. This is the equation number 4. This is rewritten as that like the z minus 13x1. This z minus 13x1 minus 11x2 equal to 0. But in this case, no select variable are present in this case, right? So this is equal to 0. But for the first constraint, 4x1 plus 5x2 minus 1500, or this is equal to 1500 plus s1. Add the unused storage space 4 and 5. This is the 4 and 5 for the unused storage space, right? Storage space. So the 4s1 plus 5f2 plus s1 equal to 1500. Similar in the next case, 5 plus 3. 5 plus 3, this raw material, right? 5 plus 3, this is the 5, 15, 75. This is equal to 5x1 plus 3x2, 15 plus x2 equal to 1575. This is the second slack variable used in this equation. Similarly, for the equation number 3, x1 plus 2x2 less than equal 420. So x1 plus 2x2 plus x3 equal to 420. Then x1 greater or equal 0. Here is I equal to 1 comma 2. From the equations above, it is obvious that one feasible solution that satisfies all the constraints is x1 equal to 0, x2 equal to 0. Then x1 equal to 1500. Similarly, in this case, S2 equal to 1575 and S3 equal to 420 and Z equal to 0. These are the numerical values of S1, S2, S3 and Z also. Here Z is 0, S1 is 1500, S2 is 1575 and S3 is 420, right? Then move to the step number 2. Step number 2. For this case, from equation Ti, which limits the maximum value of x. But the maximum value of x for this equation is here x1 equal to minus 3 by 5. Just you take this equation, right? This equation. For this two case, this equation, right? x1 equal to 3 by 5x2, x2 by 5x2, and then divided by 5 here also. This will give say 315. So the all elements, if I am x1 taking x1 equal minus 3 by 5x2 minus 1 by 5x2 plus 315. This is the equation number 6. And substituting this equation into equation number 5. Where is the equation number 5? This. Put these all is here x1. Put x1, replace x1 to this value. And you will get a different types of solutions like z minus 16 by 5 x2 plus 13 by 5 x2 equal to 4095 plus 13 by 5 x2 plus s1 minus 4 by 5 x2 equal to 240. Similarly, in the case of x1 plus 3 by 5 x2 plus 1 by 5 x2 equal to 315, and the 7 by 5 x2 minus 1 by 5 x2 plus s3 equal to 105, right? So these are the transforming equation by the x1 function, right? And this is the equation number 7. And following the same analysis procedure used in step 1, it is clear that in equation B2, if S1 and X1 equal to 0, then X2 equal to this. And from the equation number C2, right, it is a value of X1, X2 equal to 0. Then this is this value and this value. Follow these steps and come to this here. Then what is the value of this? Z equal to minus 13x1, and this is the general value. And make this table. Make this table. First is for basic variable. Here you write Z, x1, x2, x1, x2, x3. This is the right hand side value. This is the upper bound of entering variable. Upper bound of the entering variable. Just right here these variables, right? And in any iteration, a variable that has non-zero values. The variable has non-zero values in this solution called the basic variable. So this is the this S2, this is a non-zero variable, right? This is here non-zero variable. So first you take this solution and then go to the step number 2. Step number 2, identify the variables that will assign a non-zero value in the next iteration so as to increase the value of the objective function. And this variable is called the entering variable. This variable is called the entering variable. It is that non-basic variable which is associated with the smallest negative coefficient, which is associated with the smallest negative coefficient in the objective function. If two or more non-basic variables are tied with the smallest coefficient, select one of these arbitrary and continue. And then move to the step number 3. Here we will identify the variables called the leaving variable, which will be changed from a non-zero to a zero value in the next solution. Non-zero changed from a non-zero to a zero value in the next solution, right? And this is the step number 4 for the simplex method. Just to see in this slide for the step number 4. In step number 4, enter the basic variable for the second tabulation. The row sequence for the previous tabulation should be maintained, with the leaving variables being replaced by a entering variables. So these some are the leaving variable and some are the entering variables. Then again draw this second tabulation at the end of the first tabulation. This is this and this is the feasible solution for this case. So the step number 4, step compute the coefficient for the second tabulation. A sequence of the operation will be performed so that at the end of x1 column in the second tabulation will have the following coefficient. The second tabulation is the following feasible solution. This will be a x1 315, x2 equal to 0, si 240, S2 0 and S3 105 and Z equal to 4095. This is the feasible solution of this question, right? And then move to the next section of this problem, and then this is the third tabulation at the end of the second of the final iteration, right? And then the step number 6, it will give a value of x1 equal to 270, x2 75, s1 equal to 45, s2 equal to 0, s3 equal to 0, and z equal to 4335. In the step number 6, check the optimality. The second feasible solution is also not optimal because of the objective function rho a2 contains a negative coefficient, and another iteration beginning with step 2 is necessary, right? Then this is the solution. You will say optical production program for industrial companies. The company can maximize its sale income 4335. This is the maximized sale income 4335, right? And the marginal values of addition resources and the marginal values of the addition resources. Just like this, there will be no surplus of raw material or production time, but there will be the 45 units of unused storage space. This is the solution of this question here. Then comes to the next section. This is the MCQ section, right? So for the MCQ sections, this is a question number first, right? So what is the MCQ question for the question number first is here? Just you see in this slide and find the correct answer for this question. The operation research OR, which is a very powerful tool, which is a very powerful tool for the research, decision making, operations, and non-operations. So just to try to search the answer for the question. What the correct answer? It is the powerful tool for the decision making. It is the powerful tool for the decision making. So this is the correct answer for this question. The correct answer for this question is here. Then move to the question number 2. Who coined the term of operation research? Right? Who coined the term of operation research? The correct answer is here D. A and B answer. GF, GF MC Klosky and the FN Stephenson. So this is the correct answer for this question. So this MCQ question is very important for any topic. So we solve very quickly. For the question number third MCQ, the term operation were coined in which year? This question related to the operation research. This question related to the operation research history. So The term operation research was coined. The term operation research was coined in the year of 1940. This is the correct answer for this question, right? The correct answer for this question is here 1940. And then move to the fourth question. This is innovative science. This innovative science of the operation research was discovered during discovered during the World War, Civil War, World War First, World War Second, or Industrial Revolution. This innovative science it was starting from World War Second, right? World War Second. Then move to the next question. This is the fifth question. Operations research was known as the ability to win a war without really going to a battlefield, fighting war, and both A and B without really going to a battlefield or fighting, right? So the correct answer for this question is here D. Correct answer is here D. This is the correct answer, right? So operation research was known as an ability to win the war without really going into a battlefield or fighting, right? Correct answer is both A and B. Then move to the sixth problem. Who defined operation research as scientific method? Who defined the operation research as a scientific method of providing executive department with the quantitative basis for decisions regarding the operations under their control? Means, which person said that? None of the above. E.L. Arnav and M.J. Nitjor, P.M.S. Blackett, Morse and Kimball, 1946. So this is the right answer. Morse and Kimball said this statement, right? Then move to the next question. The next question for the MCQ is this. Who defined operation research? Who defined operation research as scientific approach to problem solving for executive management? Problem solving for the executive management. E.L. Arnav, P.M.S. Blackhead, H.M. Wagner, and none of the above. 7. H.M. Wagner. This is the correct answer for this question. H.M. Wagner said that the operation research is a scientific approach to problem solving for executive management. Right? This concept given by the H.M. Wagner. Right? 40. Uh, Slide number 40. And this is the question number 8. Who defined operation research as an ad for the executive in marketing his decision by providing him with the quantitative information based on the scientific method of analysis. CKT, HM Wagner, EL and none of the above. What will be the correct answer for this question is here? A. A is the correct answer for this question. Right? CKT said the operation research as an ad for the executive in marketing his decisions by providing him with the quantitative information based on the scientific method of analysis. Right? This is given by the CKT. And operation research has the characteristics. Operation research has the characteristics. It is done by a terms of scientific, mathematician, academics, and all of the above. Is a term of scientist, right? This is the correct answer. Then move to the second last question. The there is a great scope for working as a team to solve problems. To solve, sorry for this question. There is a great scope for working as a team to solve problem of defense by using the operation research approach. Economics, administrator, statistics and technician, and all of the above. All of the above. Correct answer for the question is all of the above. All type of person uses the operation research. All type of person uses the operation research, and these are economists, administrator, statistician, and technicians also. Right? So this is the correct answer for this question. And right. So move to the references. Just wait for this. These are the differences for the simplex method topics. Introduction of operation research, Hiller, FS in library, and G, J, CBS public service. Operation research, Macmillan, and foundation of optimization, ICS and Phillips, Creative Francis. These are the some reference books for this chapter of simplex method. In the next coming lecture, I will discuss about the different types of complex problem related to the simplex method and the complication in simplex method. What type of complication related to the simplex method? Formulas, linear programming model, formulation of linear programming model, right? And some solution. Regarding these are the some good questions for this next class. For the next class, I will discuss this type of problem in the next class. So, thank you, all of you, for this lecture. Thank you.